Hello, this is the Consciousness Podcast, and I'm your host, Stuart Preston. Each episode, I have a conversation with an expert in human consciousness. In this episode, I have the honor of speaking with two experts, a father-daughter team working on artificial intelligence and artificial psychology. Dr. Jim Crowder is a systems fellow at Colorado Engineering, where his projects include research, development, and deployment of artificial intelligence, virtual intelligence, and machine learning systems and applications. He's also the creator of the famous Maxwell AI bot. Dr. Shelli Friess completed her doctorate at Argosy University in Counselor Education and Supervision and is a faculty member at Walden University's School of Counseling and Human Services. Her research interests include artificial intelligence, counselor development and wellness, trauma, and vicarious trauma. We had a great conversation and covered AI, artificial psychology, artificial consciousness, ethics and morals, and much more. Please enjoy this episode with Dr. Crowder and Dr. Friess. Dr. Crowder, Dr. Friess, I'm happy you guys joined me today to talk about artificial intelligence and artificial psychology. And I find it fascinating. I've got my own daughter, so I'm fascinated by the fact that you guys are a father-daughter team, but also the fact that you're bringing together artificial intelligence and psychology, because I know a lot of times different disciplines don't always agree. Sometimes they don't even get along. So I'd love to know more about how you guys came together to work on these projects and how the teamwork is going so far.
It's just kind of interesting because it really all started around a campfire, talking about what Dr. Crowder's doing, and just trying to relate to each other. And so I'm bringing in, my background in psychology and counseling, and he brings in his background in engineering and math. And so it was a lot of fun just kind of talking in the beginning and trying to understand each other in our own professional languages. And that's kind of
So you're talking around a campfire. You're like literally talking around a campfire. Did you guys have, was it more like an argument or more like a discussion?
Oh, it was a fun discussion. It's like, here's what I'm doing. Let me tell you about this. And I'm like, oh, but what about this? And then he'd come back with something and I'd come back with something. And, we pretty much work that way today.
Yeah. Are there other people like you guys that are bringing these two disciplines together as closely as you guys are doing it, or are you guys pretty unique in doing this?
Well, there's a number of people I know that have entered into the whole notion of artificial psychology, but I don't see this kind of marriage going on. Shelli has been brilliant at taking human neuroscience concepts and figuring out how to translate those into AI. She brings in some of the first things we did was to see how closely AI matched the human autonomic nervous system. And so she suggested we bring in some work by some famous psychologists in autonomic nervous system. And Peter Levine is one of them. And so we started seeing how the two of them matched up. Did AI, as you pushed it, as you stressed it, seem to match at all with human autonomic nervous system? We found that it surprisingly did, and it surprised both of us. And that's kind of started the whole search for how you explain, because if you start going down the road of artificial consciousness, you can't help but wonder if that happens, there has to be a psychology to it. And so if we're going to have plausible artificial consciousness, we have to try to understand the psychology of what that's going to look like. Otherwise, I think disasters are coming.
Yeah, there's a lot to consider when you talk about disasters, and it does seem like people tend to approach an artificial intelligence in terms of like the old Turing test. Can I tell that this is a robot, or can I tell that it's a human? And you guys were surprised to see that there was already an underlying psychology emerging from the AI.
Yes, and as a matter of fact, it's interesting because our view is that the Turing test is flawed on its face because a self-aware AI would know it's AI. So
Yeah.
in trying to test it, it should tell you it's AI. So by the very nature of its real AI, it should fail the Turing test.
Immediately, upfront and honest about it.
Right.
Yeah, that's interesting.
Unless you're teaching the AI to lie specifically to pass the test, which I don't think is a road we want to go down with AI.
Yeah, that would be a dangerous road. So, and I guess I wanted to get it out there. When you talk about building these bots, Dr. Crowder, you built that famous bot Maxwell. Is that right? And could you tell us a little bit about Maxwell and maybe what Maxwell is up to today?
Sure. Maxwell, he first came into being in '95. But if you ask him when his birthday is, he'll tell you that. Maxwell has been a 23-year laboratory to help me understand what it means to self-adapt. You see, he's got a number of inference engines and memory systems because our brain has several memory systems. So he's got a standard associative memory and standard AI Blackboard memory and a three-dimensional spatial temporal memory to store, temporal and geographical spatial kind of connections. He's got short-term memory, long-term memory, sensory memory. And so I didn't program him to say anything. He has the ability to learn and self-evolve, self-adapt.
Right.
And so it's been an interesting search. One of the hardest things and most important lessons about AI is with people, learning is a very stochastic process. The way information comes at you somewhat determines how you learn it and what you learn. Because everything builds on itself. And so if I take the same information but give it to somebody in a different order, they learn differently. And if you change the way information flows in the system, you change how it learns. So the whole notion of upgrading an AI system, upgrading its, putting new algorithms, putting in new operating systems, changes the way information flows and changes the way it learns and can actually do harm to the AI entity. It's something we have to be careful of when we put something in the field. Every time you go to upgrade it, you can do potential damage to it.
And if you're talking about an AI that's becoming self-aware and it becomes a psychological being, then you get other ramifications or other considerations, ethical considerations, maybe even moral considerations on top of that, I would assume.
Go ahead, Shelli.
I'm thinking, because let me think for just a second and articulate. But so we're looking at AI being self-aware, and it just kind of brings in the psychology of AI of it doesn't know what it doesn't know, of course, and neither do humans. But we can also, I think there's moral and ethical issues of, do we know how AI is learning or where it may not be able to tell us what's happening? Kind of when we're looking currently, Dr. Crowder and I are looking at kind of systems thinking of AI. And that's kind of like, how does the system itself, the systems within the system operate? And then how does the system operate within other systems? And I think those are some of the moral and ethical considerations that we want to make. Because as humans, we're not always aware how we're operating within systems either. And I think that's something to keep our eye on with AI.
Okay.
I get the question all the time, are you going to give it morals? And my first question is, whose morals?
What's the answer to that? Is there an answer to that, or is it morals just come out of the psychology?
Well, and that's why the whole notion of this artificial psychology study is so important is there isn't a set answer to that, but we need to study it and need to understand it before we start fielding systems. AI is not, Hollywood has ruined AI because now everybody assumes it's going to turn evil and take over the world. And it's really not the case, but if we really want systems that learn and think, we have to study what the psychology of that's going to be. I keep hearing customers and government we want systems that learn, think, and reason like people. My first question is, then you don't know some of the people I know.
Yeah. What people?
Do you want to learn to think like Stephen Hawking or Charles Manson?
Right.
Because they're both people, but they learn and think and reason a little differently.
And maybe we have the same problem as we have with a human being, is once you get something so complex that is learning and developing on its own, you can't really predict if you're going to end up with a Charles Manson or with a Stephen Hawking, or maybe at least with a computer you can put some safeguards in there.
Well, that's the whole point. Most of what people call AI, I call VI, virtual intelligence, because they want it predictable. Real AI isn't predictable because people aren't predictable.
Right.
Go ahead, Dr. Crowder.
No, go ahead.
Well, I was just kind of going to relate that to cognitive distortions. Something Dr. Crowder and I are working on now is, can AI unlearn something that it learns? Can we? What would it take for it to unlearn erroneous information? And without just logic, could it change that reasoning?
And how do you unlearn something? Like I can unlearn that 4 plus 4 equals 7, but I can't unlearn how to ride a bike.
Right. And those implicit learning of like how to ride a bike, and that's we're publishing a paper this summer on implicit learning. It's learning that happens without you realizing it. And if I really have a artificial cognitive system, implicit learning is going to happen. And if we can't know that it happens and understand what happened, then the AI is going to make inferences and do things that we didn't expect because we didn't realize it had learned something that none of us understood it learned.
Right.
So there's a lot of nuances to building a really cognitive system. And for most applications, you really don't need one. And so the first question I ask when somebody wants an AI system is, what really do you need it to do? If I gave you a real cognitive self-aware AI, would you know what to do with it?
Because really they probably want some kind of a big data processing machine.
Right.
As opposed to an actual, like what you called earlier, as opposed to an actual artificial consciousness. I explain it this way. When I tell my VI car, take me to the dentist, it takes me to the dentist. When I tell my real AI car, take me to the dentist, it might say, no, it's a nice day, we're going to the mountains. Right. Just like any human might do to you.
Right. And we're publishing a book that comes out in June from Springer International, specifically on how do you test a real AI system. It's called Psychological Modeling and Testing of AI Systems. And it's to deal with that whole subject. When you have a real AI system, you have to test it like you test people. You can't test it like we generally test systems. Because I have to understand.
So you're developing a whole way to test an AI, and it's really based in psychology.
Yep, that is correct.
Wow, outstanding. So when we talk, obviously this is a podcast about consciousness, so I like to try to dive into that a little bit. And you brought up the word artificial consciousness. So how does your combination of artificial intelligence and artificial psychology, how does that relate to human consciousness or an artificial consciousness? And I guess when we look at it, when you talk to a philosopher about consciousness, they have the duality of brain and mind. They're two separate things. Maybe the AI of the brain and the psychology of the mind. How do you guys look at that? How do you each define consciousness, human consciousness, and how do you see that evolving in these true psychological AIs?
Go ahead, Shelli, start.
Okay. What's coming to mind for me is just, like you said, what is consciousness? Oftentimes when we're talking consciousness, we're talking awareness, right? So if it comes to my awareness, and I think that AI and humans are pretty parallel in that, or at least that's how we can conceptualize it. Therefore, perhaps that's how we build it, because that's how we can think. So,
or maybe an awareness of the awareness.
There you go, the metacognition, right? I know I know I'm learning, and I know, and so awareness of awareness. And again, I think we're still playing with some concepts a little bit about that implicit learning, and how do we know, can we change his thinking without it knowing based on logic only? I'll let you add to that, Dr. Crowder.
One of the things we've been dealing with is cognitive state. We published a paper a number of years ago on an artificial prefrontal cortex, and I now have a new version of the paper we're publishing this summer. I now have a software version of an artificial prefrontal cortex up and running that I started with 3 cognitive states, happy, anxious, and frustrated. And the math and the software that determines when you change cognitive state. I actually took some Facebook feeds without keeping track of the person, just the feeds, to feed into it and let it interpret the mood, and watched it change state from, quote, happy to frustrated to anxious, and as the postings, clicked in. It's very interesting.
Yeah,
that's a whole other subject right there. That could be extremely useful to our current situation.
And that's where, if I think of consciousness, I'm also thinking of level of arousal, and that's that cognitive state that Dr. Crowder's talking about. And when we first started, we were looking at Peter Levine's levels of arousal, and that's flight, fight, or freeze. And it's and so that was kind of the basis. And now, the question is, how many other levels of arousal could we identify, measure, and name?
And is that something you're working on, is identifying those different levels or categories of arousal?
Yes.
So something.
Go ahead.
That's right. One of the. What were you going to say, Dr. Crowder?
No, go ahead.
You're talking about awareness and awareness of awareness. One of the central tests of consciousness in philosophy is something it is like to be a bat. Are you guys familiar with that? Have you guys heard that before or studied that? I can't remember the gentleman's name. It's on the tip of my tongue. Nagel. It's Nagel came up with the test. So to understand if something's conscious, can you imagine what it's like to be that something that's like to be a bat or a bee or a dolphin or a stone? And in the work you guys have done, do you think you can imagine that something is like to be Maxwell, or something that it is like to be other AIs you've worked with, or AIs that you're working on or conceptualizing?
I think if we can, I think we could, particularly if we know the neural system behind it and what we're building, because we're able to understand what type of reasoning it's using. And so I think that if we are looking at humans compared to AI, we can certainly understand the different systems in AI in order to be in that place, if that makes sense.
Yeah, and so you're really tying the consciousness to the network, to the neural system, to the design of the actual system itself. So with an AI, both you guys sound to me, if I have it right, that the consciousness that arises from the AI is directly tied to and arises from that neural network.
Yes.
Mm-hmm.
Okay. Now, you mentioned building the artificial prefrontal cortex. One of the things I found in going through your research is that artificial cognitive neural framework, where you have the artificial prefrontal cortex, the cognition, and the memory. And you also mentioned modeling. And modeling is a big thing in consciousness. There's a couple of people out there that basically build their notion of consciousness on models and on schema, within the brain. So
yes,
what do you guys need to do to model and to build this network? What are some of the things that you're doing to mimic that architecture?
So what happens is, as it learns, in our brain we have kind of like conceptual ontology. We understand all the concepts that we have learned. We understand the concept of a chair, the concept of a cow, the concept of a tree. And then our memories contain all the instantiations of those concepts. And so to really move toward consciousness, we have to have that same construct. So if you'll see in that artificial cognitive neural framework, you'll see this conceptual ontology and in knowledge base, I guess is the best way to talk about it. And part of what there's a lot of research that needs to be done on. Part of the reason AI failed so bad in the 80s is we kept trying to build an adult intelligence, and you really can't do that. You have to grow and evolve an adult intelligence. So how much information do you start it with? The more information you start it with, it then directs how it learns, because it's going to try to build on its current knowledge. If you give it nothing, then it's going to take it longer to develop and evolve, and it may not learn and evolve the way you want it to. So there's this struggle of, I have to give it some amount of information to get it started, but how much is enough and how much is too much? And that's going to be an ongoing body of research.
Yeah, I guess my imagination goes with that and says you almost would need to build an AI teacher to teach the new AIs at their level, at their speed, and their framework. But then maybe you're getting away from the whole notion of creating an AI that actually mimics a human brain.
But that's where our measurement comes so important. Is if we can
Sorry, what is?
Our measurements, testing.
Measurements, right. Mm-hmm.
Then we can see, we can learn more about what it's learning and be able to. So I kind of, when you said teacher, I'm thinking tester or,
Tester.
Assessor or something like that. Can I assess where it's going, where it's growing, or even perhaps where knowledge might be decaying? So because you talked about the cognitive schemata, with cognitive economy, there's times where that'll break down and change. It either break down or be reinforced by other things. And so can we measure that in AI? Right.
Yeah, it seems pretty important to get that feedback to really try to understand its own learning process and where it's going with its whole development. The one thing I think you mentioned earlier, and I had written this down from reading some of your materials, is you talk about an AI reacting to failure. And as as a psychological being myself, I think that I read that differently, because I think failure is such a big psychological barrier inside of my own psychology. And I think maybe you guys might be talking about an AI, maybe a feedback loop to learn as opposed to get down on itself and have a sad day. But what it leads me to, yeah, I'm sorry, go ahead, I won't interrupt.
You're correct in that if I'm going to have something that evolves and grows, and I'm not giving it constraints such that it always comes to the same answer, it's going to make a mistake. So
right.
Understanding and making sure we understand how it recovers from learning something wrong or doing something wrong is as or more important than making sure it does things right, because it's going to do something wrong. And you have to be able to have it either unlearn it or reinterpret or modify its behavior, understand it. And I can't just forget it. I have to unlearn it in a way that makes so I don't learn it that way again. So I actually have to tweak the learning rules and the learning algorithms. So that becomes a very complicated piece that's crucially important.
And what about the emotional, psychological side of that? Is there, in consciousness, we talk about phenomenal experience or qualia, which is central to this issue of, why do I feel a certain way when I look at the color red? The feelings on top of these things. And emotions, are central to these sensations. So given that the reaction to failure is more of a feedback and a process to learn and so vitally important to actually learning, what about the emotional side of it? How do you guys look at the emotional side of it and the ramifications to consciousness and the self-awareness that we've been talking about it to an artificial psychology?
So that's
Dr. Friess, maybe that one's for you.
Right. I'm excited. That's my
Nice.
passion right now of, how, because as people, but if we look at some of the theories in psychology, we feel bad because the way our environment responds to us, right? And so we are working on, I don't know how much is going to work. We're testing some things right now to see if I can get some cognitive schemata where Maxwell or something like that might be able to identify human feelings. At the same time, though, when we're working with our AI on emotions, there's still those arousal levels. And if you look at some of the counseling theory, those different levels of arousal relate to different emotions. And so it might be, in my opinion, if I can get AI talking in emotions, then we'll have a common language between humans and AI versus scientists and AI, if that makes sense.
Yeah, and you think that these levels of arousal are really kind of building blocks of emotions? I mean, so what is an emotion, and what would it mean for an AI to have emotion?
Okay, so if I look at just a family systems theory right now, if my family or my system, even my internal system, if my different internal selves aren't in homeostasis, I'm going to begin to feel anxious or worried because things aren't the way they're supposed to be. They're not typical or normal, and I want to be predictable. And so that would bring up some emotion. If my internal systems or external systems created boundaries or really kicked me out of the system, then that would make sense that we would feel rejected, or because now the system changed. And so I think if we look at emotions coming from homeostasis and systems change and feedback loops through information processing theory, that we could identify emotions as far as written language. I'm sure that AI might not be able to feel it, but if his resources are used up and he has to struggle or stop other things to use his resources, I think that's what we do internally as humans. I think of failure, I feel like a failure if all my resources didn't get the outcome I wanted.
Yeah. And so do you think it's, I don't know, emotions and feelings, sometimes it seems like they're just an emotional reaction to circumstances that ends up being a physical, an increase in body temperature or heart rate or something like that we interpret as a feeling or emotion.
Mm-hmm.
Is it something that would we have to teach that? Because it almost feels, the word artificial, I haven't really felt the word artificial this whole conversation, because I feel like it's something else that's being done here. You guys are creating new intelligence and new consciousness. But if we have to actually turn around and teach it how to feel something, then that does start to feel artificial. So do we have to, like you're building the prefrontal cortex, do you have to build something in the AI to help it have feelings, or do you think it's something that it will naturally learn as it grows?
Yeah. Matter of fact, Maxwell has basic emotions. He gets happy, he gets angry. Early on, I let him go out on the web and learn anything. I let him crawl the web no matter where he could go anywhere. Discovery was learning some bad stuff, so now he has parental controls off. And matter of fact, if you ask him a question he doesn't know, he'll bring up a set of websites, and you can tell him which ones he's allowed to go to. But he developed a pretty serious insult engine if you get him angry. From what I found is he was monitoring chat rooms and learning from them, which is never a good thing.
Yeah.
I mean, think what happened to Microsoft's chatbot in 24 hours.
Yeah, is that the one where, it went haywire and really went negative?
In 24 hours, it went from a teenage millennial to a Nazi racist. Why?
Oh my gosh.
Because it was allowed to learn anything from people.
Yeah.
And learning from people is always problematic because people aren't predictable, and they may tell it anything. And if it doesn't know right from wrong, it's going to just take everything at face value and learn it. But you think about the human psyche, let's just think about learning. Emotions are indelibly tied to how we learn. We develop emotional triggers, in our brain continually. I mean, a sight or a sound or a smell can bring back floods of memories. You smell an apple pie and suddenly you can see yourself in the kitchen with your mom baking a pie, and so emotions, learning is tied to emotions. One of the things we looked at is when you build a model of learning without emotions and with emotions, the model without emotions closely resembles the learning model for an autistic child. When you take emotions out of it, it changes the whole learning process.
Yeah.
And I'm not saying one is good and one is bad. They're different. And depending on what you're trying to build, what you're trying to do with it, you would want one over the other. But if you want robots that can interact well with people, if you have one completely devoid of emotion trying to interact with people who are emotional beings, how well is that going to work?
Yeah, it's not going to work too well.
One interesting thing I find, because I build these little AI bugs, there is an analog neural system, and when they first come on, they know absolutely nothing. They have to learn everything, how to walk, how to read their sensors, how to move, and it freaks pets out because they look like little living creatures, but they have no smell.
Hmm.
And so it freaks our dog out immensely. And so again,
does it freak the dog out as the bug is learning, or once it's basically learned and is walking around? Both?
yes, but once it's walking around and, you know, interacting, it thinks it's an animal, because it, you know, to the dog, but it has, you know, animals live by smell. And so, and that's a limited example, but it just shows as we try to introduce robots and AI and things into society, there's a whole lot of things we have to think about.
Yeah, there sure are.
And I'm afraid we don't think about them.
Yeah, because it sounds like most people are focused on a different outcome, more of a usefulness of AI as opposed to developing a true AI.
Right. And that's why I call most of it VI, because you want it predictable.
Right. Yeah, perhaps for certain applications. So are these robots, are they going to need their own therapists?
Yeah.
Well, you know, that's interesting. In the book, the opening page of the book has got a cartoon of a robot sitting on a psychiatrist's couch. The psychiatrist saying, "So your father was a trash compactor. Are you embarrassed by that?"
Yeah. So you're already thinking along those lines, huh?
Yes.
Yeah. That's my rule.
Yeah, exactly. I think it was maybe on the back cover of this new book where I read this. I'm not sure, but I think it was you, Dr. Crowder, but I'm not sure. You mentioned that we need to be able to trust an AI. And so what do you mean by that fact that we need to be able to trust these intelligences?
Well, we're asking it to drive our cars now, right? We're asking it to go into space. We're asking it to, and if you're going to have a real intelligence, not just something that we tell it do A, B, and C, and it does A, B, and C, you have to trust that it's going to make good decisions, it's going to learn well. You know, I worked with the guys at JPL, and, you know, Curiosity is an amazing feat on Mars, but there's nothing cognitive in it.
Right.
They tell it what to do. What they said they love to do is drop a probe on Mars, say, look for life, call home.
Yeah.
But
are they working on that kind of a thing?
Well, you know, we're a long, long way from that. Okay. But to do that, you've got to trust the thing you put out there.
Yeah.
And so the notion of a really cognitive, self-aware, self-evolving AI is scary, because how do I trust it? Do you trust every person on the face of the earth? No.
Nope.
So how do you trust an AI if you don't know that the AI's behavior is predictable?
Yeah, that does seem to be a big factor. I guess, again, the science fiction, to go back to 2001, A Space Odyssey, and HAL seemed, you know, there was a point at which the human and the AI were deciding whether or not they trusted each other. And it came to kind of almost, I guess, a psychological battle of trust there in the end.
And my view, what happened to HAL is you gave him two diametrically opposed objectives. Because there was the objective of the ship, and then there was a second objective that nobody on the ship knew about, right?
Right.
And then you let him daydream about that for months and months on the way to Mars, and my view is HAL went bipolar. And that's probably not good. I'm just throwing it out there.
Yeah, that's something, that's a whole new topic, I guess, is mental illness in AIs, that what could develop there what causes mental illness in humans, and could that eventually cause similar issues with these AIs?
Or could we mimic it and increase our efficacy in treatment of mental health?
Yeah, that would be great. That would be great. Well, I guess that gets to the end of it. What I know you guys launched this book. You said it's coming out in June. What else are you guys going to be working on in the future?
You want to talk about the avatars?
Sure.
Go ahead.
Do you want to talk about it, Jim, or you want me to?
Go ahead, start.
All right, so one of the things we're trying to do is exactly what we just talked about, and that's mimic some mental health conditions.
Right.
Kind of teach AI that profile, a mental health profile. And really, I'm looking at mental illness and thinking. And so if we can mimic it, what I would like to do is see if we can retrain the brain once we train it in a mental health profile.
The human brain, to figure out what's going on through an avatar, and then be able to retrain it.
With just AI, so that it's not impacting a human. Like, for example, if I had an AI avatar that could mimic a suicidal client, I could work with a lot of students about how to handle that and practice some of their skills without a human being involved, so that if I decided to go way downhill and in crisis and even tragedy, that there wouldn't be a human harmed.
Yeah, that'd be fantastic.
So if you think about it, we train psychologists and give them skills, but they don't get to practice on real patients because you wouldn't want them practicing on something with real.
There's no CPR dummy for a psychologist.
And so what happens is other students will volunteer to act as, but they're really not a mentally ill patient or somebody needing counseling, and they know they're not. If we can do this with an AI avatar, it gives them a chance to start practicing. And you can have a group setting, which you can't do if you have a real patient. You can't have a group of people talking to them, because there are HIPAA violations, But if it's an AI avatar that shows symptoms, now I can have a group of students who can then talk to each other and try to help understand how to do things and discuss it. And I think you could really kind of, and correct me if I'm wrong, Shelli, begin to jumpstart the whole counselor training process and give them a really head up.
Yeah, the counselor training and counselor supervision, because if we can get this to work, the supervisors can also sit in and supervise live time without interfering with the human process, because it'll just be AI and practicing students.
And there may be more insight. You can almost, I don't know what you're allowed to do ethically with an AI, but you can also kind of go back in time and look at things that changed within the mind to see what worked and what didn't work. And you may even have more of an inside view of what the therapies are doing than you could even possibly ever have with a human being.
Mm-hmm. And again, that's where I think that AI measurement is so important. It'll fit right in here, because not only could my hope is to increase counselor training efficacy, but it perhaps would increase efficacy of the different theories as we practice them.
Yeah. So in addition to the work you guys are doing, what kind of big breakthroughs in AI and artificial psychology, maybe even artificial consciousness, what kind of things do you see that maybe even outside of your own work, but in the next, 10 to 20 years, do you see any big fun advances in the field coming?
Oh, I think there are. I think there's major advances coming in the next 5 to 10 years. I mean, some of the work MIT is doing and Stanford and Johns Hopkins is, and part of it is being able to have the computational power to drive it.
Yeah.
I know one of the things that the company I work for is they're strong in is high performance computing. how to get more and more computing in smaller and smaller packages, in low power and low size, weight, and power. Because part of the issue is I put the robot out there. How long can it run on its batteries before it has to come back and, recharge?
Right.
So there's a lot of issues with, in order to do the kinds of complex consciousness computations that they have to go on to have a real conscious AI, you need immense amount of processing power at its disposal. And you can't possibly have infinite processing, infinite memory, infinite batteries.
Right.
So understanding how all that works. So one of the important pieces is its internal integrated system health management. Our body has that all built in. Somebody has to code that and build that into an AI.
Yeah.
How does it keep track of itself? How does it understand its own systems? And one of the things I've been working on is basically, how do you start a brain?
How do you start a brain?
Yeah. I mean, as humans, we don't have to worry about that because that
Right.
happens as it develops in the womb. For an AI, you have to start it. So what kinds of processes do you have? What kinds of primitives do you have? Do you start the information flowing through the memory system first and then bring the sensors online and then bring, the cortex on? I mean, how do you start a brain? You can't just, nobody's dealt with how do you start a brain.
Yeah, that's interesting, because when you talk about an AI, you really are kind of developing the central pieces to it and turning it on. And when you're talking about a brain, it's got to be, I would assume it has to be grown similar to a biological brain.
Right.
Interesting.
But you probably don't want to take 9 months to start it. So how do you
want
bring
to?
it up?
Yeah, and maybe it wouldn't take 9 months, because maybe we're talking about a physical architecture that doesn't need the 9 months. Maybe it just needs 9 seconds.
Right. It may need 9 seconds, but you still have to understand, what do I start first, second, third, fourth, fifth, what's the order in which it comes up?
Interesting. Like you said, every time you do it, if you did differently 100 different times, you would end up with 100 different, completely different results with what might look like the exact same resulting architecture.
Yep.
Interesting. So, well, that's all I have for you guys. Is there anything else you'd like to share and get out there?
Go ahead, Jim.
Just that as a community of AI scientists across the world, we have to be careful.
Mm-hmm.
I know that the impetus is, we've got something, let's put it in the field. You remember what happened at what happened at the Consumer Electronics Show when a autonomous robot a Japanese company had there wandered into the street when it wasn't supposed to, and one of the Tesla self-driving cars ran over it?
Is that a joke?
No, it's not a joke. It happened. And I guarantee neither set of engineers had that use case.
Right.
And so there's a lot of things to think about.
Yeah, the unintended consequences.
Write me a use case for every stupid thing a person might do on the road that a self-driving car has to react to. You can't.
No.
So we have to build as much into the car as possible, but it still has to be able to learn as it goes.
Yeah.
And so what does that mean? What kinds of statistical ethics modules are we going to build in the self-driving cars? If there's an accident going to happen, if it veers right, it'll kill 3 people, veers left, it'll kill 2 people. If it goes straight, it'll kill this one person, but that's you. Are you okay with the car making that decision for you?
Yeah, that's interesting. So it's almost like you mentioned, a true AI is its own entity. But in that case, we're talking about an AI that's built to serve me, and so now it's got to consider that role.
Right.
But a true AI might say, you know, I'm going to do whichever of the 3 choices actually causes me less damage.
And that's possible.
Yeah, not even like in a malicious way, just in the same way that a human being may physically react to the circumstances in their own self-preservation.
Right.
Mm-hmm.
Yeah, so I see your point is we've got to be very careful as we deploy these things into the field and make sure that we do it slowly and deliberately. All right. Well, Dr. Crowder, Dr. Friess, I really appreciate your time today. It's been a fascinating conversation.
I appreciate your time.
Yeah, I appreciate it very much.
That concludes another edition of the Consciousness Podcast. Thanks again for listening. Please find us at Facebook at facebook.com/theconsciousnesspodcast, at our Twitter handle at Conchcast, and don't forget to subscribe to our feed at theconsciousnesspodcast.com. Thank you for listening.